let's talk about factor trees. Every number that exists can be created using prime numbers. The cool thing about every number in the world is that it has its own unique set of prime numbers that it can be created with. It's kind of like the key to the number, the basics, what it's really made up of. To find that, we use a factor tree. Take the number 24. Pretty basic number. I'm sure you've used it a lot. We're going to break the number 24 down by finding out which two numbers can multiply together to make 24. Well, you think about it, you think some more, and you notice that 24 is even. So because it's even, you can divide by 2. 24 divided by 2, you might have to show some work off to the side, or you might just know that half of 24 is 12. Now there's two different numbers that you get here. One of these numbers is prime, the other is not. Here's how you can tell if a number is prime. If you try to break this number down, and the only thing you can come up with for two numbers that multiply together to make it are itself and 1, you don't need to go any further. Because if you'll notice, you still need to break down this number, which is going to be itself and 1. Then you need to break down this number, which is itself and 1. It gets very repetitive, and you'll be stuck there for the rest of your life if you keep going like that. So what we're going to do is we're going to circle it to show there's no other way to break that number down. Then we're going to go over to this 12. Let's break this 12 down. What two numbers multiply together to use 12? To make 12. Now, you could come up with a different answer than I get, but as long as it's mathematically correct, we'll come up with the same numbers as the end product. I'm going to use 3 and 4. 3 is a prime number, 4 is not. So I have to break 4 down even further. 4, well, that's pretty simple. We have 2 and 2. What this means, 2 times 2 are 4. 4 times 3 is 12. 12 times 2 is 24. This can be written as the factors of 24. We have 1, 2, 3 2's and a 3. 2 times 2 times 2 times 3 equals 24. But that's long, and that takes a while to write. So we're going to narrow it down a little bit more. We're going to condense some things. There are 3 2's here. So instead of writing all those 2's out, we're going to write 2 to the third power times 3. What this means, 2 to the third, is that you're going to see this 2 3 different times. These things mean the same thing. 2 times 2 times 2 is the same thing as 2/3. There you have it, the factors of 24. 2 to the third power times 3. Let's take a look at the number 72. Big number. So we've got to think, how can we break this down? Well, when you've got a big number like this, think back to your math rules. I know it's even, so I know it can be automatically divided by 2. Or, if you're really thinking, you might think of the 3 rule when you're multiplying numbers, and that it's, if you add up all the digits, 7 plus 2 is 9. So because you get 9 and that's divisible by 3, we know this number is divisible by 3. Now I have to figure out what times 3 will get us 72. Uh-oh, looks like I'll have to do some division now. 72 divided by 3. 3 goes into 7 twice. 2 times 3 is 6. Left with that 1. Drag down the 2. 3 goes into 12 4 times. Oh, look. 3 times 24 is 72. Let's break down that 24 again. I don't want to do it the same all way, so this time I'm going to divide 24 into, let's say, 4. 4 times what gets us 24? Well, let's say 4 times 6. 6 times 4 is 24. We remember that. Let's break down this 4 into 2 and 2, and then break down the 6 into 2 and 3. So the factors of 72, I'm going to tip this, sorry to throw you off, are 1, 2, 3. 2 times 2 times 2. 3, 3 times 3 times 3. Let's condense that. Let's write it a little bit simpler. How many 2's do we have? 1, 2, 3 2's. 2 to the third power times how many 3's do we have? 1, 2 times 3 to the second power. Those are the factors of 72. You can also write it the way we wrote up top, and sometimes you will need to write it that way when you're using GCF and LCM and a couple other times. But for the final condensed version, you're going to want to use the exponents. Let's take a look at one more number. Let's take a look at the number 19. I want to do a factor tree for the number 19. But what do you break 19 down into? Well, you can't. So you're just going to circle 19. The factors of 19 are just 19. You would also include 1, but 1 is a special number that can be multiplied into any other number. So it's kind of like a given that it's there. 19 and a ton of other numbers are one of these lovely numbers called prime. A prime number is a number that you circle on a factor tree. So if we're going to make a factor tree of 6, these are prime numbers. A composite number are the numbers that still need more roots or more branches. 6 is a composite number because it's composed of prime numbers. It can be broken down into prime numbers. And then there's breaking an exponent back down. So if we had 14 to the third power, we would know that that means 14 times 14 times 14, because you will see the number 14 3 times.